A divided by R equals omega.
V divided by R equals omega.
Okay, but if I did the change in V is equal R times the change in omega, and then divide both sides by time,
That's acceleration.
That's acceleration.
what is this?
This is alpha.
Alpha.
Oh my god.
That's the relationship. So, and here I have an R alpha, because I got rid of one of the R, so it's just R times alpha, so that's just A. So I've now broken this down into 3 equations, and I've gotten rid of all my angular stuff. Now I can just add the 3 equations together. On the left-hand side here, I have FT2 and FT2, they're gonna cancel. I have FT1 and FT1, they're gonna cancel. I have M1G minus M2G equals M1A plus M2A plus 1/2 MPA. Up until now, this part right here would not have existed, because we were dealing with an ideal pulley and an ideal rope. There's no friction between them, the pulley's not turning. But now with the pulley turning, we have this added to it. I can factor A out, since all these terms on the right-hand side have A in it, and then divide by what's left over. And so I end up with an acceleration equal to M1G equals M1G minus M2G. That's the driving force, divided by, yes?
I have a question. Would M1 and M2 be able, can we cancel those out since they're both on each side?
Can we cancel those out?
Yeah, M1. Can we cancel them?
No.
Because they're all different numbers.
You're suggesting just dividing by M1 or?
Yeah, can't we cancel out M1?
But then we'd end up with M2 divided by M1 here. Every term has to have M1 in it as the same factor. And I'm left with M1 plus M2 plus 1/2 MP. And again, when we were dealing with something like this up before chapter 9, that term would not be there. And I think on that note, I think it really is time. I know what the problem is. That clock's not, has stopped. It wasn't fast by 15 minutes before, it was slow by 11 hours and 45 minutes.
Because I didn't do the daylight savings time?
No, it's,
11 hours? Totally stopped.
the battery's almost dead.
Sorry, what I said. I
Thank you.
don't listen. I'm not understanding. This dog. That's what I was asking. I just want to. I have to ask you. But I was just wondering, yeah. I was wondering if you were going to talk about this.
Yes.
On the master set with the small part and the big part, I explained it using the logic, because whenever I did the equations, without plugging in answers, I was getting that the change in velocity would be bigger for the smaller car, but because it's multiplied by a mass smaller than the larger one,